Namespaces in Kubernetes provide the means to logically divide a Kubernetes cluster into logical partitions or virtual clusters. For example, if there are two application teams, A and B, operations personnel can create one or more namespaces for each team. Each namespace can be configured with its own access control rules and resource quotas. Users assigned to a namespace will have a role level privilege that limits their access only to their assigned namespaces. However, this simple two-level hierarchy is not practical at scale because administrators with a cluster role privilege need to be involved every time a change needs to be made to a namespace. For example, as their needs evolve, the application team may need additional namespaces for their application, need increased quotas for their namespace, need to reduce resources for the namespace, potentially also want to rename the namespace. Since it's not possible to provide the application team users with cluster administrator privileges, one of two things happen organizationally. Cluster administrators land up absorbing the ongoing cost and effort burden. Or application teams become frustrated because of unnecessary delays in turnaround times for the requests from administrators. Is there a better way? Rafay has introduced a unique market-leading capability called Workspaces to address these challenges. With a workspace operations team, can completely offload lifecycle management of Kubernetes namespaces to workspace administrators without having to provide them with excessive cluster-wide privileges. They can provide a self-service experience for application teams. That is, they should be able to handle namespace lifecycle management without requiring any form of involvement by the operations personnel. They can prevent noisy neighbor issues related to multi-tenancy on shared clusters by allowing the configuration and enforcement of resource quotas for a workspace. They can dramatically reduce the ongoing operational costs by avoiding a dedicated cluster per application operating model. Well, let us see how we can configure and implement workspaces using the Rafay Kubernetes operations platform. Consider a situation where two application teams, A and B, require a Kubernetes cluster for their applications. They have multiple applications each that are fairly small, and therefore the operations team would like them to share a Kubernetes cluster to save costs. The Rafay org admin creates a unique project per application team. That is, the first project is called Team A, and the second project is called Team B. Now let us share a cluster from the production project with both Team A and Team B. When you access the new projects, notice that the shared cluster is now available in both projects for application deployments. Now let us assign workspace administrators to our two projects. As an org admin in the org, let us start by adding the first workspace administrator for Team A and then follow up by adding the second workspace admin for Team B. Let us now log in as the workspace admin for Team A. Notice that this user has privileges to create namespaces, but is not allowed to manage the lifecycle of Kubernetes clusters. So as the workspace admin for team A, let us now create two namespaces, Apple and Banana, on the assigned cluster. Now, once the namespaces have been successfully created, let us deploy an application in each namespace we just created. For our demo, let us deploy a simple Kubernetes YAML-based workload called Echo Apple and Echo Banana to the Apple and Banana namespaces respectively. In a few seconds, both workload deployments should complete. Now, let us look at whether the Team A workspace administrator actually has access to just the namespaces they have or all of them. Let us use the web-based Zero Trust kubectl shell to the remote cluster and attempt to list all namespaces. Notice that this operation is blocked for the workspace admin because he does not have a cluster role or cluster administrator privileges. Now let us attempt to view the Kubernetes resources inside one of the namespaces that was created by the workspace admin. Note that the workspace admin can successfully view all Kubernetes resources in the namespaces they create and administer. Now let's look at resource quotas. Since both teams A and B are sharing the same Kubernetes cluster, we do not want them stepping over each other by monopolizing resources, resulting in noisy neighbor issues across workspaces. The Rafay platform allows org admins to specify resource quotas for each project and every namespace. These quotas will then be enforced on the cluster, ensuring that every workspace has to operate within the configured resource quota. Let us now specify a resource quota for the Team B project. In this example, we have specified a total of 300 MCPUs for CPU and 300 MIB for memory. Now let us log in as the workspace admin for the Team B project. Let us now create a namespace called Alpha. Since a resource quota is enforced, notice that the admin is prompted to either accept the default value provided for the namespace or override it with custom values. Let us accept the default quotas for the Alpha namespace and create it on our cluster. Let us kubectl to the cluster and describe the newly created Alpha namespace to check if the quotas are actually really enforced. Now let us create and deploy a workload to this namespace. Notice that our workload is requesting 500 MCPUs and 500 MB memory. This is well beyond the resource quota allocated to the alpha namespace, and therefore will be blocked from deployment on the cluster. Now let us reduce the resource request to 100 MCPUs and 100 MIB memory and publish the workload. Since this is within the resource quota allocated for our namespace, it will be successfully deployed to the cluster. Workspace admins can quickly view allocated resources for their project and current resource utilization by clicking on My Clusters Utilization. In our example here, notice that the Workspace admin for Team B is able to quickly determine that 300 MCPUs and 300 MIB resources were allocated to the project, but only 100 MCPUs and 100 MIB memory resources are currently consumed from the quota. In summary, with Workspaces in Rafay, organizations can implement cost-effective multi-tenancy, enabling multiple teams to share a Kubernetes cluster. With Workspaces, operations personnel can offload the operations burden associated with namespace administration to the application teams and enable developer productivity. Thank you.